This is Algebra 2, Unit 8, Lesson 2 on solving square root equations. Now, we have equations with square roots in them, and the key to solving this equation lies in the application of inverse operations. So the key inverse relationship of these equations is between taking a square root and squaring. So the inverse of squaring something is taking the square root, and the inverse of taking a square root is squaring it. So knowing that, let's solve each of the following square root equations, all right, and check it. The square root of x is equal to 7. In order to solve this, to get the square root off the x, I would have to square both sides. So I'm going to square this, and I'm going to square this. Because the square root of x squared, power over root, is just going to be x. And 7 squared is 49. Square both sides. Square root of 49 is 7. That works. The square root of x minus 3 equals 5. Square both sides. And I'm going to square the 5. The square root cancels out the square, so this is going to be x minus 3. 5 squared is 25. Solve for x, add the 3. So x is equal to 28. There we go. All right, so if I plug in here, 28 minus 3 is 5, or 25. The square root of 25 is 5, and it works. All right, 2x minus 1 equals 4. Square both sides. 2x minus 1 squared, square root of 2x minus 1 squared is equal to 4 squared. The square root cancels out, or the square cancels out the square root, so that gives you 2x minus 1 is equal to 16. Add 1. 2x is equal to 17. Divide by 2. X is equal to 8.5. Now, solving for the x variable on this is just like solving for a regular equation. You want to get the x alone. So 3 times the square root of x minus 4 equals 20. To get the x alone, first thing we'd have to move is the 4. So we would add the 4. 3 times the square root of x is equal to 24. Divide by 3. The square root of x is equal to 8. And then I would have to square both sides to get rid of the square root. So it's just like solving any regular equation. The square root of x squared is just going to be x is equal to 64. You want to get the square root alone and then square both sides. So if we plug in here, the square root of 64 is 8. 3 times 8 is 24. Minus 4 is equal to 20. All right, 2 times the square root of x plus 5 plus 7 equals 13. We want to get the square root by itself. So first thing we want to do, subtract the 7. So that's 2 times the square root of x plus 5 is equal to 6. All right, I want to get rid of this 2 before I want to take this square, so I'm going to divide by 2. And I get the square root of x plus 5 is equal to 3. Square both sides to get rid of the square root. The square cancels out the square root, leaving just x plus 5. 3 squared is 9. Subtract the 5. X is equal to 4. So if I plug in here, 4 plus 5 is 9. The square root of 9 is 3. 2 times 3 is 6, plus 7 is 13. And it works. Okay, last one of these. You want to get the square root by itself, so we have to move the 4. Add the 4. 5 times the square root of 3x minus 2 is equal to 40. Get rid of the 5, divide by 5. The square root of 3x minus 2 is equal to 8. Now, to get rid of the square root, we have to square both sides. The square cancels out the square root. You get 3x minus 2 is equal to 64. Add the 2. And divide by 3. X is equal to 22. All right, so if I plug in here, 3 times 22 is 66. Minus 2 is 64. The square root of 64 is 8. 5 times 8 is 40. Minus 4 is 36. And it works. All right, so now that we know how to do this, which of the following is the solution to 3 times the square root of x over 2 equals 15? See if you can work that out. We'll go over that one in class tomorrow. Now, dealing with square roots, a more complicated scenario arises when a squared expression is equal to a linear expression. The next exercise will illustrate both the graphical and algebraic issues involved. Okay, so let's look at this system of equations. Y equals the square root of x plus 3 and y equals x plus 1. if I solve this graphically, let's see what it looks like. Well, I know y equals x plus 1 is a line. So if I take my line, my y-intercept is going to be 1, and my slope is also going to be 1. So it's up 1 over 1, up 1 over 1, up 1 over 1. And if I draw in my line, let me see, I'll go down here so that I can see it. There is y equals the square root of x plus, or y is equal to x plus 1. All right, now, the square root of x plus 3 is the square root of x function shifted 3 to the left. It's under the radical, so it's going to shift opposite way. So 3 to the left. So the 0, 0 would be at the square root of x, so shifted 3 to the left. 1, 2, 3 would be right here. All right, now if I do this on my calculator, I have y equals square root of x plus 3. I can look at my table and figure out my values. Negative 3 is 0, negative 2 is 1, 1 is 2, and I can graph those points. All right, so negative 3 is 0, negative 1, or negative 2 is 1. Then the next point could be 1 is at 2. Right there. And then the next one would be at, if I scroll down here, I can find another point. 6 is at 3. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so this is basically the square root graph shifted 3 to the right, or 3 to the left, I'm sorry. See if I can draw that a little neater. I'm not good with curves. That's a little better. Okay, so this is y equals the square root of x plus 3. Okay, now, the solution to a system equation is where the graphs intersect. Well, where do the graphs intersect? They intersect at that point right there. So that's at 1, 2. And that's where they intersect. All right, now, solve this system algebraically for only the x values using substitution below. All right, so if I take the square root of x plus 3 equal to x plus 1, y equals y equals. So set them equal to each other. I want to solve this for x. All right, so I have to square both sides. And then I have x plus 1 squared. Okay, now the square is going to cancel out the square root, leaving just the x plus 3. But what is x plus 1 squared? It's a FOIL. It's x plus 1 times x plus 1. All right, so to solve that, I get x squared. If I FOIL this out, it's 1x and 1x is 2x plus 1. Well, that's a quadratic equation. So we want to get it equal to 0. So I'm going to move these over here. So I'm going to minus the x and minus the 3. And that gives me x squared plus x minus 2 is equal to 0. Factor, factor, factor. That's going to be x and x. The factors of 2 are 2 and 1. And if it's got to be plus 1 in the middle, it's going to be plus 2 and minus 1. Set them equal to 0. And so x is going to equal negative 2, and x is equal to 1. All right, so algebraically, I found two values of x that work. All right, x equals negative 2 and x equals 1. But but we only found one x equals 1 right here. Okay, so this would have a y value of a different value. Now, why does your answer from part A contradict what you found in part B? All right, there should only be one solution. There should only be one solution where the graphs intersect. Okay? But algebraically, there are two. Okay, so what we have here, x equals 1 is actually the intersection point. That is the answer that we would have. X equals negative 2 is called an extraneous root. It is a root that we get algebraically that cannot be used in the answer. If we plug x equals negative 2 into this problem, negative 2 here, you would get the square root of negative 2 plus 3 is equal to negative 2 plus 1. You get negative 2 plus 3 is the square root of 1. Negative 2 plus 1 is equal to negative 1. Is the square root of 1 equal to negative 1? No, it's just equal to 1. So this is an extraneous root because these do not, because of this having to stop here, you can't have x equals negative 2 as your answer because it's not part of the graph. It does not work for this particular one. Okay, so it does not intersect at that point. So this is what's called an extraneous root. So you cannot use this root, x equals negative 2, because that's not where the lines and the graphs intersect. So oftentimes roots are introduced by various algebraic techniques that for one reason or another are not valid solutions of the equations. These roots are known as, just as I said, extraneous, and can always be found by checking within the original equation. Okay, so whenever you have an x in the problem, as not the square root but on the other side, and you have to square something, a lot of times you will end up with an extraneous root. Not always, but if you do, you have to reject any extraneous roots. Okay, so let's solve letter A. All right, to get rid of the square root, we have to square both sides. So square root 2x minus 3 squared is equal to x minus 3 squared. All right, when you square a square root, you get 2x minus 3. X minus 3 squared is x minus 3 times x minus 3. Make sure you FOIL that. So 2x minus 3 is equal to x squared minus 6x plus 9. Minus 3 is minus 6. All right, quadratic equation, get it equal to 0. So minus the 2x and add the 3. Watch your signs. You get x squared minus 8x plus 12 is equal to 0. Factor, factor, factor. All right, if this is plus and this is minus, that means this has got to be minus minus. Factor to 12 to give you 8 would be 6 and 2. X minus 6 is equal to 0. X minus 2 is equal to 0. I get x is equal to 6, and I get x is equal to 2. Okay, so I have two values of x. Do they both work? Let's see. Here's my check. Yes, you do have to check these. All right, 2 times 6 minus 3 is equal to 6 minus 3. All right, 2 times 6 is 12, minus 3 is 9, is equal to, square root of 9 is equal to 3, so 3 is equal to 3. That one checks. So x equals 6 is a solution. All right, let's look at x equals 2. 2 times 2 minus 3 is equal to 2 minus 3. The square root of 2 times 2 is 4, minus 3 is 1, is equal to 2 minus 3 is negative 1. The square root of 1 is 1 equals negative 1. Is that always true? Not always. So this one is extraneous. That one is the extraneous solution, and we would have to reject this one. So x equals 2 does not work. Okay. All right, see if you can do B yourself, and we will go over this in class the next day.